Namaste, I am Dr. Pramod from Pharma Knowledge Forum. In this session, I am going to discuss UV visual spectroscopy and Lambert Beer Law. UV visual spectroscopy is an analytical technique that measures light absorption of sample across the ultraviolet and visual range of the electromagnetic spectrum. UV visual range is 200 nanometer to 800 nanometer. UV range is 200 nanometer to 400 nanometer. Visible range is 400 nanometer to 800 nanometer. Now question is how UV spectrophotometer works, what are its different components, what are its applicability. I am going to discuss in next slide. Simple UV visible spectrophotometer consists of a light source, a monochromator which consists of two slits, slit 1, slit 2 which is separated by a prism, a beam splitter, sample compartment which contains sample cell and reference cell, and detectors. Function of light source is to create light of various wavelength. Then light approaches slit 1. Function of slit 1 to ensure all light must travel in parallel pathway. Then light approaches prism. Function of prism to split light into its wavelength component. Then light approaches slit 2. Function of slit 2 to ensure light of only selected wavelength to pass through it. Then selected light approaches beam splitter. Beam splitter splits light into two components of equal intensity. One part passes through reference cell, then strike on detector. Second part passes through sample cell and then strike on detector. Detector detect photons, that is a light, and converted into electrical current, and that current is measured by computer. At initial stage, as there is not any sample solution in sample cell and hence light passes through sample cell, that is I is equal to light passes through reference cell, that is I0. Hence transmittance I divided by I0 is equal to 1 or 100%. Now let us see what is the impact of sample concentration on transmittance. When sample concentration is 0, transmittance is 100%. Let us put sample solution of concentration X in the sample cell. Then transmittance decreases to 50%. Now let us increase the sample solution concentration by X unit. Then transmittance decreases to further 50% and it becomes 25%. Now let us increase again sample solution concentration by X unit. Then transmittance decreases further to 50% and it becomes 12.5%. It means on every incremental increase of sample concentration, there is a 50% reduction of transmittance, and it follow the exponential relationship between concentration and transmittance, and it follow the following equation. Now question is, what is the practical applicability of this exponential transmittance equation? I am going to discuss in next slide. Since it is an exponential equation, it has little practical applicability. That is why Lambert Beer brought a new unit, that is A absorbance, which is equal to minus logarithm of transmittance, that is T. And this is the final absorbance equation, and this equation follow the linear relationship between concentration X and absorbance. Lambert Beer Law states that the absorbance of solution is proportional to concentration, molar absorbance coefficient, and optical path length. Now question is, what does a UV spectrum look like? What information does it provide? I am going to discuss. UV spectrophotometer provides the data in the form of an absorption spectrum. The absorption spectrum is normally presented in the form of graph where y-axis represents absorbance and x-axis represents wavelength. Peaks in the spectrum known as the absorption peak indicates the wavelength of light that is absorbed by the sample. This is the typical UV spectrum of one of the bulk drug that is paracetamol. A spectrum look like that. It has two maxima. One is about 200 nanometer. The second is about 245 nanometer. Now question is, what are the application of UV spectrophotometer? I am going to discuss in next slide. UV spectrophotometer is widely used in the industry for identification test, for quantification like assay, content test to find out UV maxima, for UV analysis to find out color absorbing substances, to find out pKa. UV spectroscopic terms chromophore. Chromophore is a group of atoms responsible for UV visible absorption of the molecule. For example, carbon-carbon double bond, carbon-oxygen double bond, nitrogen-nitrogen double bond, aromatic ring, etc. Red shift, a change in absorbance to longer wavelength is called red shift. Blue shift, a change in absorbance to shorter wavelength is called blue shift. Sample preparation solvent, generally those solvent are used for the UV analysis having the no UV absorbance or low UV cutoff like water, acetonitrile, methanol, ethanol, etc. About this session, I am on mission to train more and more pharma professional by sharing my skill-based knowledge. But it can be only possible if connect with my channel, subscribe my channel and take advantages of my skill-based knowledge. Thank you.